Hello everyone. Today we are going to learn about wide in the context of neural networks. In the context of deep neural networks, wide refers to the number of neurons or units in a given layer, particularly in the hidden layers. A wide neural network has a large number of neurons in one or more of its layers, which allows it to capture a broader range of features from the input data. For instance, a network with 1,000 neurons in a single hidden layer can be considered wide compared to a network with only 10 neurons per layer. So, what are the benefits of using a wide neural network? The first benefit we'd like to talk about is feature representation. A wide network can capture more features and details from the input data due to the large number of neurons. The second benefit can be mentioned as complex functions. So, a wide neural network can approximate complex functions better than a narrow network with fewer neurons. The third benefit is less depth. Wide networks often have fewer layers but compensate it with a higher number of neurons per layer. Also, sometimes simple problems can be solved effectively with wide networks without the need for deep layers. And the last benefit can be mentioned as parallel computation. Moreover, more neurons in a single layer can benefit from parallel computation, which can be more efficient on certain hardware architectures. However, there may be some challenges with wide networks also. For instance, the first challenge can be overfitting. Wide networks can be prone to overfitting, especially if there is not enough data to train the model, as they may learn noise in the data rather than the underlying pattern. The second challenge can be computational resources. Wide neural networks require more computational resources like memory and processing power due to the large number of parameters. The third challenge can be mentioned as training time. Training can be slower due to the increased number of neurons and parameters. So, when to use deep networks and when to use wide neural networks? So, deep neural networks focus on having many layers with fewer neurons per layer. They are better at capturing hierarchical patterns and complex relationships in data. On the other hand, wide neural networks focuses on having fewer layers with many neurons per layer. They are good for capturing more features at a single layer level. So, a hybrid approach can be used, which can combine both wide and deep components to utilize the benefits of both architectures. The wide part captures simple and memorized rules, while the deep part learns complex and generalizable patterns. Now, let's move on to the exercises. So for the first exercise, it's quite simple and we are just doing a linear operation here. So x1 will be getting multiplied with this weight. So 2 into 1, 2. Then we add the bias, which is 0. So we will get 2 from the output. So x1 is 2 and the output is y1, which is 2. So we can see that we only have one neuron in the first layer and one neuron in the second layer or the output layer. Then the next exercise, we are adding one more input here, which is x2. So the input layer is getting wider as we are getting two inputs here. So these two input samples will be getting multiplied with these weights and then we add the bias. So 2 into 1 plus 1 into 1 will give us 3 and 3 plus 0 we will get 3. So x1 is 2, x2 is 1 and then the weights are 1 and the output is 3, which is y1. So you can see that this input layer is getting wider here. The next exercise, we have two inputs like the previous example, but now we are getting one more output here. So the output layer is getting wider here. So x1 is 2, x2 is 1, and then this will be getting multiplied with this set of weights and we add the bias, we will get 3. And then for this set of weights, we can get 2 into 1 plus 1 into minus 1. So 2 minus 1 will give us 1 and then 1 plus 1 will give us 2. So y2 will be 2. So we can see that this y layer is getting wider here. So if we add one more row of weights and biases, our output will increase here. Now the next one, we are adding one more row of weights and biases. So our output layer will be getting wider. So Then we will get the outputs as y1, y2, and y3. So let's calculate the value of y3. So these values of x1 and x2 will get multiplied by these weights, and then we add the bias. So 2 into -1 plus 1 into 0 will give us -2, and then plus 3 we will get 1. So y3 will be 1 here. Now you can get the concept how we are making each layer wider than the previous example. Next example, if we want to make the first layer or the input layer wider, then we have to add one more input. So we are adding one more input, and for that input, we are adding one more column of widths. So now let's calculate the value of y3. So these values will be getting multiplied by this row of widths and biases. So 2 into -1, then 1 into 0 plus 3 into 1. So -2 plus 3 will give us 1, then 1 plus 3 will give us 4. So y3 will be 4 here, and x3 is 3. So we are adding one more input here, and the input layer is getting wider. Let's make the input layer wider than previous example. So we have to add one more input here. And for adding one more input, we have to add one more column. So then we will get the value of y3 here. So these values of x1 to x4 will be getting multiplied by this row of weights and biases. So 2 into -1 plus 1 into 0 plus 3 into 1 plus 1 into 0 will give us -2 plus 3, which is 1. Then 1 plus 3 will give us 4. So y3 will be 4 and x4 is 1 here. So you can see that as we are adding one more inputs, we are getting the input layer wider. And as we are adding one more row of weights and biases, we are getting the output layer wider. Next exercise, we want to make this layer wider again. So we are adding one more input here. So for this input, we have to add one more column of widths. So now these values from x1 to x5 will be getting multiplied by this row. So 2 into -1, -2, then 3 into 1, 3. So -2 plus 3 will give us 1. And then 2 into 1 will give us 2. So 1 plus 2 will be 3, and then adding the 3, we will get 6. So y3 will be 6 here, and x5 is 2. Now we are making it wider again. So these all values will be getting multiplied by this row of weights and biases. So 2 into -1, -2, plus 3 into 1, 3. So 1, and then 2 into 1, 2. So 2 plus 1 will be 3, and then 1 into -1 will be -1. So 3 minus 1 will be 2, and then 2 plus 3 will be 5. So we put here 5. And you can see that all the inputs are getting multiplied by all the rows of weights here. So all the inputs are connected to all the outputs here. So you can see that it is a fully connected network. And as we are adding one more input, this network is getting wider. That means it is increasing horizontally rather than vertically. If it were increasing vertically, we could say that it is a deep neural network. But as we are adding more inputs, so we can say that it is a wide network. And with the network getting wider, we can capture more inputs here, or we can say that more features here. Now the next exercise, we are adding one more input. So this layer will get one more input and will get wider. So for this input, we have to add one more column of weights. For this value of y2, we need to multiply this x1 to x7 with this row. So we get 2 into 1, 2, then -1 into 1, -1. So 2 minus 1 will give us 1, and then 2 into 1, 2. So 1 plus 2, we will get 3. So y2 will be 3 here. And again, as all the inputs are getting multiplied by all the weights, so this is a fully connected network. We want to make this layer wider again, so we are adding one more input, and for that input, we have to add one more column of weights. So now from this x1 to x8 will be getting multiplied by this row of weights for this value of y2. So 2 into 1, 2, then -1 into 1, -1. So 2 minus 1 will give us 1. And then this 2 into 1, 2, and then 1 into -1 will give us -1. So we will get 2 here. So this value of x8 will be 1 here, and the value of the output y2 will be 2 here. Now let's try to understand the concept of deep and wide together. So you can say that we are adding one more layer in between the input layer and the output layer. We can call this a hidden layer. So for this hidden layer, or H1, This x1 will be getting multiplied by this. So 2 into 1, then we add the bias, which is 1. So this will be 3. So x1 is 2. And then for the value of h1, we can put 3. And from x1 to h1, the weight value will be 1 here. And then this value of h1 will be getting multiplied with these. So 3 into 1, 3. Plus we add the bias, the value of the output layer will be 5. So y1 will be 5 here. And from h1 to y1, the weight value will be 1. So we are having an input layer and output layer, and this layer in between is the hidden layer for us. And in each layer, we only have one single neuron. Now, we will try to make the hidden layer wider. So we have to add one more neuron in the hidden layer. So as we are adding H2 here, this hidden layer is getting wider now. Let's calculate the value of H2 now. So this X1 will be getting multiplied by these rows. So 2 into 1 plus 0, we will get 2. And then these 2 will be getting multiplied with this row of weights and biases. So for this H2, we have to add one more column, as we have seen in the previous examples. So now this H1 and H2 will be getting multiplied by this row of weights and biases. So 3 into 1 plus 2 into 1, 5, and then adding the value 2, we will get 7. So you can see that for an extra neuron, we have to add one more column of weights, as we have seen in the previous examples. And another thing, let's try to remember. So wide means more neurons in a given layer, especially in the hidden layer. So we are making the hidden layer wider here. Now fill up the values here. So H1 is 3 and H2 is 2. And the value of Y1 will be 7. And from H1 to Y1, the weight will be 1. And from H2 to Y1, the weight will be 1 also. Next, we are adding one more neuron in the hidden layer. So the hidden layer is getting wider again. Let's try to fill up the value of H3. These two will be getting multiplied by this one, and then we add the bias, which will give us 1 here. And now these values of H1, H2, and H3 will be getting multiplied by this row of weights. And for adding this H3, we have to add one more column of weight. So 3 into 1 plus 2 into 1, 5. And then adding the bias, which is 2, we will get 7. So H3's value will be 1. And from H3 to Y1, the weight value will be 0. And the value of Y1 will be 7 here. Now, we are adding one more neuron, which is H4. So X1 will be getting multiplied by this. So 2 into 1 minus 2 will give us 0. And then these all 4 values will be getting multiplied by this row. So 3 into 1 plus 2 into 1 will be 5. And then we add the bias, which is 2. We will get 7. So H4 will be 0. And from H4 to Y1, the weight value will be 2. And we will get the output as 7 for Y1. Now we will try to add 2 more neurons on this example. So for these 2 neurons, we have to add 2 columns of weights here. So this X1 will be getting multiplied by this for H5, and for H6, X1 will be getting multiplied by this. So 2 into minus 1, minus 2, then adding 3, we will get 1 here. And these all values from H1 to H6 will be getting multiplied by these values. So 3 into 1, 3, plus 2 into 1, 2, 5, and then 1 into 1, 6. And then adding the bias, 6 plus 2, we will get 8 here. So H6 will be 1, and Y1 will be 8. So from H5 to Y1, we will get the weight value as 0. So H5 to Y1 will be 0. And from H6 to Y1, we will get the weight value as 1. So H6 to Y1 will be 1. Next exercise, we are again adding 2 more neurons in the hidden layer, and it is getting wider. See, we have only one input and one output in these examples, but we are making the hidden layer wider. So for calculating the value of H8, we will multiply 2 into 3, 6, plus adding the bias, which is 0, we will get 6. And we will multiply all these values from H1 to H8 with this row. So 3 into 1 plus 2 into 1, 5. And then 1 into 1, 6. And then 6 into minus 1, minus 6 will give us 0. Then adding the bias, 0 plus 2 will get the output as 2. So Y1 will be 2, and H7 is 4, and H8 is 6. Now we will stop at this. So as the previous example, we only have neurons from H1 to H8 in the hidden layer. but we are adding one more input. Let's see what is happening here. So the input layer is getting wider. X1 is 2 and X2 is 1. And for adding one more input, we have to add one more column of weights here. So let's try to calculate this H8. So these two values will be getting multiplied by this row of weights and biases. So 2 into 3, 6 plus 1 into 1, which will give us 7. Then adding the bias will give us 7 also. So H8 will be 7. Let's try to fill up the value of H8, which is 7. Now, we have to multiply from H1 to H8 with these rows. So 3 into 1, 3, then 2 into 1, 2, which will give us 5. 2 into 1, 2, so 5 plus 2, 7. And then 2 into 1, 2. So 7 plus 2 will give us 9. And then 7 into minus 1 will give us minus 7. So 9 minus 7 will give us 2. So 2 plus 2 will be 4. So Y1's value will be 4 here. Next, we have a simple change in our example, which is we are now going to perform linear operation. Also, we will use the ReLU function. So we know that the ReLU function will return the number as it is if it gets 0 or any positive number, and it will return 0 if it gets a negative number. So for this value of A1, this X1 will be getting multiplied with these rows. So 2 into 1, 2 plus 0 will give us 2. So the value of A1 will be 2, and the value of A2 will be 2 into 1 plus 1 will give us 3. So A2 will be 3. So from X1 to A1, the weight value will be 1. And from X1 to A2, the weight value will also be 1. So you can see that we are getting 1 neuron in the input layer, and we are getting 2 neurons in this layer. So now we are adding one more layer here. So 2 neurons in the A layer and 3 neurons in the B layer. So you can see that it is getting deep here, but it is getting wider in each layer. So compared to A, B is a wider layer. So now let's try to find out this value of B1. So for B1, this value of A1 and A2 will be getting multiplied with this row. So 2 into 1, 2, and then minus 1 into 3. Minus 3 will give us minus 1. And as we are using ReLU here, so this will be 0. So B1 will be 0. And then 2 into 1 plus this bias 1 will give us 3. So the value of B3 will be 3. So you can see this layer is the input layer. This layer we can call a hidden layer now. And this layer we can call the final layer or output layer for this particular network. Next exercise, this network is getting deeper with another layer below the layer B or next to the layer B. And this layer C is wider than this layer B. So in terms of wide networks, we can say that C is wider than B and B is wider than A. Now, for finding out the value of C3, these values of B1, B2, B3 will be getting multiplied by this row. So 1 into 1 plus 5 into 1 will be 6. And then adding the bias, we will get 6 here. And for C4, we will get 5 into 1 minus 1, which will be 4 here. So C3 will be 6 and C4 will be 4. So we did not get any change in the values as we are getting positive numbers in the ReLU function here. Now we are adding one more layer here. So it is getting deeper, but we are getting one more neuron in this layer compared to the previous layer C. So D is a wider layer than C. So for this value of D4, we have to multiply from C1 to C4 with this particular row of weights and biases. So 2 into 1, 2 plus 6 into 1, 8. So we will get 8 here. And for D5, 6 into 1 plus 4 into 1, 10. And then adding the bias, we will get 11. So we just simply put 11. And we just put the numbers here because we are getting positive numbers and ReLU will return the numbers as it is. Now we have multiple inputs in the first layer or the input layer, and the layer A is having 4 neurons. So for this particular value of A3, we have to multiply this row with X1 to X5. So let's multiply. 3 into 1 plus 1 into minus 1 will give us 2. So adding the bias, we will get 2 here and ReLU function will return 2. And for this value of A4, we simply multiply 2 into minus 1 minus 2, then adding 1 will give us minus 1 and ReLU will return 0 here. So the value of A3 will be 2 and value of A4 will be 0. Now we have 5 neurons in the input layer, 4 neurons in the hidden layer, and the last layer B, we have 3 neurons. So in terms of wide, X is wider then A, and A is wider than B. So for the value of B2, these values from A1 to A4 will be getting multiplied by this. So 4 into 1 plus 2 into minus 1 will give us 2. So we will get B2 as 2. So B2 will be 2. And then 3 into 1 and adding the bias will give us 1. So B3 will be simply 1. We are not getting any negative values, so we just simply put the positive values in B2 and B3. Next exercise, we are adding one more layer at the last layer. So C1 is the least wide in this network. So for this value of C1, we have to multiply this 3. So 3 into 1 plus 1 into minus 1 will give us 2 here. And then for the value of C2, 3 into 1 plus 2 into 1 will give us 5, and adding the bias will give us 6. So C1 will be 2 and C2 will be 6. We did not get any negative values, so we just put the values as it is. And you can see that this network is getting more deep, but in each layer, it is getting less wide. Now the last example. It is deeper than the previous example, but this D layer is the least wide in this network. So in terms of wide, X is greater than A is greater than B is greater than C, and C is greater than D. So for this value of D1, we just multiply these two values with this row. So 2 into minus 1 plus 6 into 1 will give us 4, and then 4 plus 1 will give us 5. So D1 will be 5. So I hope with the explanation of this video, you have cleared your idea of deep neural networks and wide neural networks, and how can we make a network deeper or wider. I hope that you found this video helpful. Thank you.